Alright, yesterday we talked a little bit about what a vertical what asymptotes are. Today we're going to specifically focus on vertical. Okay? In Algebra 2 we mostly focus on vertical and horizontal, so today we'll start with vertical. Okay? So consider this function and complete the table and sketch the graph. Right? So I'm going to start a new document. No, I don't want to save the old one. I'm going to start a graph. And do you remember how to get the fraction looking thing into your y equals? Okay, control divide will make it look like a fraction. Okay, I'd really rather use that than parentheses because parentheses really get confusing. Might as well make it look like what we want. Okay, 2x over x minus 4. Okay, so that's what it visually looks like. Let's go look at our table. So control T. So when x is 1, I'm going to scoot this over here for just a second. When x is 1, y is, hopefully you can tell that's negative 2/3, negative 0.66 repeating. Okay. When x is 2, y is negative 2. When x is 3, y is negative 6. When x is 4, it says error. When x is 5, we're at 10. And when x is 6, we're at 6. And when x is 7, we're at 4 2/3. Okay? Now, I'm going to take just a moment real quick and go ahead and graph this so I see what the graph looks like. I have it recorded on my paper. Okay? So when x is 1, y is negative 2/3. When x is 2, y is negative 2. When x is 3, y is negative 6. X is 4, error, so I know there's nothing there. When x is 5, y is 10. When x is 6, y is 6. And when x is 7, y is 4 2/3. Okay, so it looks something like that, correct? And when we compare it to our graph here, it does look something like that. Now we can only see that much of it on our paper because that part of it's gone, so we're good. Okay, so what about a little bit closer here? All right, I'm not sure if you know how to change your table settings, so we want to go to menu and look at our table specifically, and we want to edit our table settings. Okay, now we want to start our table start, we want to start it at 3.5, tab over. How do we want our table to step? How do we want our table to change? Well, hopefully you see that we want it to change by tenths. Okay, I know from here to here is not a tenth, but other places, let's go ahead and make it by tenths. So 0.1, and then tab until OK is highlighted, and then hit enter. Okay, so 3.5, when x is 3.5, y is negative 14. When x is 3.8, gotta scroll down just a little bit. My calculator's being weird. I don't know what it just did. We're just going to ignore that part. Okay, ignore this column right here on mine. When x is 3.8, it's negative 38. 3.9 is negative 78. 4.1, see I have an error again like I did on my other table at 4. It's undefined, actually is what it says on our calculator. 4.1 is 82. 4.2 is 42. And 4.5 is 18. Okay? So what's happening? What's happening as you plug in numbers closer and closer to x equals 4? Well, the y values are getting really big, like this. See, they're getting really big, or what are they doing the other way? Really small. Okay? Jump back up here to this question right here. How can you tell that an asymptote occurs at x equals 4? How can you tell? On our calculator, on the table, on the calculator, it actually says undefined. or error, like I wrote. Okay? So go back down here. What kind of asymptote is this? Well, if it's happening right here, what kind of line is that? Hopefully by now you've figured out that it's a vertical asymptote, because that's what the worksheet is called, but we'll get there in a minute. Okay? It's a vertical line, so it's a vertical asymptote. Alright? So use the tables to determine the location of such asymptotes for the following functions, and then we'll check it graphically. Okay? So I want my table to go away for just a second. And I need to hit tab so that my equation line will come back up. I can go in here and adjust stuff real quick. I need this to be x minus 4 over x minus 2. So if I'm just looking at the table, Control T, at 0, it's 2. At 2, there's an error, or undefined. At 4, it's 0. And at 6, it is, sorry about that, at 6 it is 0.5. So where is my vertical asymptote? Where is my undefined on my calculator? Well, it's at 2, but remember, we don't want to just put 2. 2 is a number. Where would that vertical line be if there was a vertical line there? It would be at x equals 2. Okay? So look at number 2. I'm going to get rid of my table for just a second so I can just deal with my equation. So I tab to get my equation up there, and then I can delete the top to be x plus 8. Go to the bottom, and I want this to be x minus 6. And I want to look at my table. Control T. 2, 4, 6, 8 is what I want this time. So at 2, it's negative 2.5. At 4, it's negative 6. At 6, it's undefined. Undefined. And at 8, it is 8. So where is my asymptote? Well, x equals, where's the undefined? 6. Okay? Problem number 3. Control T. Get rid of my table for just a second. Tab. Up arrow so I can manage this a little bit. I need this to be x plus 1. And I need this to be x plus 3. So enter to see the graph. Control T to see the table. When x is negative 3, y is undefined. When x is negative 1, y is 0. When x is 1, y is 0.5. And when x is 3, y is 0.6 repeating, so 0.67. Okay? Where's my vertical asymptote? Well, where's the undefined or the error in the table? That's at x equals negative 3. Any idea where my undefined might be in this particular table? Any guesses before we start? So let's go ahead and put it in. Need the top, the numerator to just be x. I need the denominator to be 2x minus 12. Control T to see my table. When x is 2, y is negative 0.25. When x is 4, y is negative 1. When x is 6, undefined. And when x is 8, y is 2. Hopefully you see the pattern by now. This is x equals 6. when there's the undefined in the y value, that's where the asymptote is. There's another pattern that I hope you're seeing, but I'm not quite sure if you are yet. Okay. Oh, that might be something new in the calculator. Look at that. Did you see that? If I come over here and press tab, then this comes up and I don't even have to go back and forth from the table. Excellent. Whoa. Sorry about that. So up here I need x plus 7. And down here I need 2x plus 3. So when x is oops, I gotta use my cursor and get back over here to my table. When x is negative 2, I get negative 5. Ooh, this one's a little different, isn't it? The way that the table changes, so I'm going to have to go adjust my table in just a minute. I can go ahead and do negative 1, and that's a 6. But I do need to go to Menu and Table, edit my table settings, and I want it to start at negative 1.5, but I want it to count by 0.5s. Because I've got to get the 1.5 and then the negative 1.5 and the negative 0.5. Okay? So when x is negative 1.5, I have an undefined. And when x is negative 0.5, I have 3.25. It might be better in this case to not have the graph there, although I can't really do anything about that. Oh, when I hit my table, it changed my table settings back, didn't it? Okay, well that's good to know. But my undefined is at x equals negative 1.5. Almost done. I know this is a little tedious, but we're almost done. Okay, so let's come back over here and tab to get my equation. I want this to be x plus 1, and I want this to be 0.5x plus 2. And hit enter. It does change my table. Oops. Click over here so I can get to negative 4. When x is negative 4, it is undefined. When x is negative 2, it's negative 1. Y is negative 1. When x is 0, y is 0.5. And when x is 2, y is 1. So my vertical asymptote is x equals negative 4. Last one. Last one. Come over here, tab, so I can get to my equation. I need this one to say x plus 1, okay. Oh, exactly, it's the same as the last problem, that's fine. Not always that way, but you know. And I need this to be x squared minus 4. So when x is negative 2, y is undefined. When x is 0, y is negative 0.25. When y is 2, ooh. Huh. Look at that. When y is 2, I have another undefined. And when x is 4, y is 0.417. Okay? So, what about asymptotes here? Vertical asymptotes? There's 2, isn't there? X equals negative 2, because that's where it's undefined in my y. But x also equals positive 2, because it's also undefined there. So my first question to you is, are these asymptotes related to the numerator or the denominator? Look back at all these problems that we just did. Specifically 1 through 3, because those are probably the easiest to see. Are they related to the numerator or denominator? Hopefully that you see that they are related to the denominator. Okay? How can the asymptotes be determined using this part of the expression? If you know that x minus 6 is the denominator and your asymptote is x equals 6, How are we finding that from this part of the expression? If you know that your denominator is x plus 3 and your asymptote is at x equals negative 3, how are we finding that asymptote from that part of the expression? Can you see it? How about if we set the denominator equal to 0 and then solve? Would that work here? X minus 6 equals 0. Add 6 to both sides. X equals 6. Would that work here? X minus 2 equals 0. Add 2 to both sides. X equals 2. Would that work here? 2x minus 12 equals 0. If I add 12 to both sides, I get 2x equals 12. And then divide both sides by 2. X equals 6. Okay? So on this side of the worksheet, what I need you to do is follow the directions, first of all. Each table shows values for rational functions. Identify the location of the vertical asymptote and then tell the function's domain. Okay? So here's the deal about the domain. If we're looking back over here on this side, let's specifically talk about number 4. Okay? If this is my function and I know I have an asymptote at x equals 6, when I'm talking about my domain, I'm saying what is x allowed to be? What are the x's of my function? Well, if I know I have a vertical asymptote at 6, I know that 6 cannot be in my domain. So I know my domain for this particular problem is all real numbers except 6. Everything but 6. All real numbers, x cannot equal 6. So wherever my domain is, that's what it's going to, wherever my asymptote is, that's what's telling you in your domain x cannot be. So if we're looking at problem number 1, my domain is going to be all real numbers but 2. X is not equal to 2. Okay? So what about problem 3 over here? What would be my domain for this particular problem? All real numbers, but x is not equal to negative 3. Does that make sense? I hope so. Okay? So on this side, find the asymptote, tell me what the domain is. Find the asymptote, tell me the domain. This is asking for you to find the asymptote without using a table. Okay? Take the denominator and set it equal to 0. Here's the denominator here. Set it equal to 0 and solve. And this is your vertical asymptote. Any questions about this? I hope you're having a great day.